This is my subtopic video for IB Biology on chi-square. Chi-square is a statistical tool used to see if there's a statistical difference between the observed and expected values. It is commonly used in practices such as genetics and business. Chi-square can be represented as this equation. X squared, also known as chi-square or the test statistic, sigma, which means the sum of, and then in parentheses, O minus E squared divided by E. O meaning all of the sum of all of your observed values, and E meaning the sum of all of your expected values. Both a hypothesis and a null hypothesis are needed when performing the chi-square test. So what exactly is a hypothesis versus a null hypothesis? A hypothesis is an educated response stating there is a correlation between an independent and dependent variable. It is often stated as a if-then statement. That makes no sense. Null hypothesis states that there is a relationship between the independent and dependent variables, but it is random. An example for both a hypothesis and a null hypothesis is, for a hypothesis, if I run a mile, then there will be a greater benefit to my long-term health. And a null hypothesis would be, running a mile will have no impact on my long-term health. Now it's time for an experiment to provide an example of when to use chi-square. For my experiment, I will be analyzing the impact of the location frogs are born on the color of the frog. My independent variable for this experiment will be the location the frogs are born in, and my dependent variable will be the color of the frogs. My hypothesis for this experiment will be if a frog is born in a warm environment, then it will be a different color than if it was born in a cold climate. And my null hypothesis for this experiment will be the location of where the frog is born will have no impact on the color of the frog. So for my experiment, my expected values will be all frogs born in a warm climate will be white, while all frogs born in a cold climate will be green. The number of trials I will be taking during this experiment is 5. So if we look at the left-hand corner, we can see a table labeled chi-square table. And underneath that is the degrees of freedom. To find the degrees of freedom, it is the number of trials you take minus 1. So for this instance, we would be looking at 4 degrees of freedom. Come over to the left side of the table, we can see the p-value on the chi-square table is an indicator of the probability the observed data we collect would happen if the null hypothesis was true. Most commonly in biology, we use the p-value of 0.05. So for this experiment, we will only be looking at the p-value of 0.05 and under the degrees of freedom 4. Starting off my experiment, I have placed myself in a warmer environment. I am currently in a savanna. For the experiment, I have created an enclosure to enclose 2 frogs of different colors to see what color they will turn out in a warm environment. I have an orange frog and I have a white frog. Now I will switch to a time lapse to quicken the process of a frog's development. Throughout this time lapse, you can see I repeatedly breeded these 2 frogs. Their names are Terry and Polly. You can also see that I am constantly making different types of name tags. These name tags were to name each trial of frogs. So the frogs that are named 1 are from trial 1, the frogs that are named 2 are from trial 2, and so on. I repeatedly continued this process throughout the span of about half an hour, and I was able to get the answer for all 5 trials. As you can see, I am constantly typing in different commands into the chat. This was to speed up the rate of time in the game, so the frogs were hatched faster, and they grew up into frogs from tadpoles faster too. The same process will be done for cold climate. So after this time lapse, I'm going to cut to my data table and show you how to perform chi-square with the data I've collected. As you can see in my collected data, in the warm climate I only collected white frogs, with trial 1 collecting 2 white frogs, trial 2 collecting also 2 white frogs, trial 3 collecting 4 white frogs, and trial 4 collecting 3 white frogs, and finally trial 5 I collected 5 white frogs. Well, in the cold climate I only collected green frogs, trial 1 being 3 green frogs, trial 2 being 4 green frogs, trial 3 being 5 green frogs, trial 4 being 2 green frogs, and trial 5 being 3 green frogs. Now, getting into chi-square. As a reminder, this is the equation for chi-square. X squared, or chi-square, equals the sum of, in parentheses, the sum of the observed value minus the sum of the expected value squared divided by the sum of the expected value. So, for the cold climate, the sum of our observed values was 17, which means the sum of our expected values would also be 17. So, when we plug that into chi-square, you get, in parentheses, 17 minus 17 squared divided by 17. When following PEMDAS, you get 0 squared divided by 17 equals 0, then 0 divided by 17, getting chi-square equals 0. And when doing the same for the warm climate, our observed values was 16 green frogs, or 16 white frogs, sorry, and so our expected value would be 16 white frogs too. And following the same principle as we did for the last equation, you would plug it into the chi-square equation, getting, in parentheses, 16 minus 16 squared divided by 16. And then 0 squared divided by 16, and then 0 divided by 16, getting chi-square equals 0. So, for both of our instances, we got chi-square equals 0. Now, when looking at our p-value and our degrees of freedom, as a reminder, to find degrees of freedom, it's the number of trials you did minus 1. So for us, we did 5 trials. So 5 minus 1 would be 4. So our degrees of freedom is 4. So when looking at the chi-square table, or the chi-square table, sorry, we can go down to our p-value, see it was 0.05, and then we go over to the 4, and we see that for our p-value for our p-value of 0.05, and underneath our degrees of freedom, we should have 9.49 or below to have rejected our null hypothesis. And since for both issues we got a chi-square of 0, we would have to reject our null hypothesis, meaning that there is no statistical difference between the color of the frog and the location the frog is born in. So this is the end. I just like to apologize for mispronouncing chi-square so often and mislabeling the sum of as sigma in the beginning of the video. But thank you for watching.